Hi, and welcome to this video on generators. So this is the 5th video in this series on intermediate Python, and in this video I want to talk about generators. From the previous video on iterators and iterables, we have a great foundation for talking about generators. Generators are typically not taught in introductory courses, and I think personally one of the reasons is simply that you don't really see the big benefit of them in really small programs. So generators are a way of avoiding having a lot of things in memory at the same time, which can be very strenuous on your system, or if you're using cloud hosting, it can be quite expensive. So generators, they are super useful to avoid this high memory usage, and today we'll look at what they are, how you create them, and I'll try to give you a kind of real-life example of how I would use them. So if you're ready, then let's head into the code. Here I have my Jupyter notebook. It's kind of empty already. There will be some real-life example that I've just pasted in here, but let me just start from the beginning. So first of all, what are generators? Well, generators, they're just a special type of iterators that have a convenient syntax and are pretty straightforward to implement. So if you remember from the previous video on iterators, you had that iterators had a next and iter method, and generators are just a special class of this, but where you can create them with a very function type syntax. I think the best way to explain this is to actually just start by creating some generators, and then afterwards we'll compare it with writing usual functions. And when I explain this now, I feel like it's a bit hard to really get the point across without having actual generators in front of me, so let's start by just writing some. Let me just write here a generator, let me call it capitalize. That should take in a list of names and then capitalize each of the names. Here I can do for name in each of the names. And then I use one of the Python keywords, namely yield. Now I yield each of the name capitalized. I think it's like this in Python. So I'm intending here to pass in a list of strings. And for each string, I call the capitalize method. And what this is saying is that it will yield or give me one of these elements one at a time. So this is the important point. It will not give me each of the name capitalized for all the names at the same time. It will just hand me one by one, and then I can use it for whatever I want. Let's try this out. Let's have some names here. Let's do my own non-capitalized. Let's have John. Hope this looks more correct, so this is probably the way to spell it. It's not a common name in my own language. This looks correct, and let's do Alex. And now I can form capitalized names by using the capitalize function on, of course, names, like this. I never ran this, so let's run this, looks good. I think what we can do now is to first of all print this out. And this will actually not give us something super useful. Here it will just say that, yeah, this is a generator object and some memory address. So it's not super useful to print generators, but they are iterators. So that means that you can iterate through them. So instead of printing it out, let's do for capital name in capitalized names and print each of these out. And here you can see them, and they have been capitalized, so the first letter is a capital letter. This is functionally how you use generators, but it's very convenient to think like, hey, wait a minute, this is just a trick, this is just a function, right? So if I do maybe here, try to write it as a usual function to compare it. So let's call it capitalize usual, maybe. We again take in some names. So let's write this pretty slowly. What we can do is to create a capitalized names list in here, and then for each name in the list of names that we will pass into the function, we'll take this capitalized names here and we'll simply append the name, and then we'll return this capitalized names. So this is one way, maybe a bit verbose, for how you'd write a function to do this. And the important thing is that if you do kind of the same thing here, capitalize names usual, and use this. And then we can use this one instead, run this. And now it's not capitalized, but that's simply just because I wrote the function wrong. So here it's append, and of course I need to capitalize. Like this, run everything again, and it works. So you might wonder, okay, we have this traditional way of writing a function that produces what we expect. So we take in a list, we capitalize each element in the list, and we have this new kind of funky generator thing that has this yield keyword And you might wonder, okay, is this any better in any way? And the answer is yes. The syntax is shorter, but not always. This is kind of just because my code here is a bit verbose. So I could have used a list comprehension here to just do return name dot capitalize for name in names. Actually, this does the exact same thing. So it's not really about code length. It's really about the fact that when I yield it, I don't have all of them in memory at the same time. So let's look at what happens here. When you loop through the list, what's actually happened is that the complete list is created beforehand. One way you could see this is to just create an intermediate cell here. So here we have this kind of thing. We can just print it and you can see, yeah, all of it is there. All of them have already been capitalized. So all of them have been transformed beforehand. But if I look at my generator instead and paste that in, it's just like, hey, this is a generator object. That's what it is. And the reason it's just saying this and not just giving you a nice output is simply that it hasn't computed anything yet. Nothing has been computed. It's first when you start to loop that something is being computed. So if I have this actual capitalized name here, the generator, and print this. So what's going on is that when you run a for loop, you're essentially saying, hey generator, give me the next one. Then it gives you IREC with a capital E, prints this out. Then it asks for the next one. Then it gives you John, capitalize it. Okay, it was already capitalized, but still it prints out John, and so on. And the thing is that it doesn't keep all of these in memory. Once it's finished with IREC and prints it out, it just lets it go. So the important point is that when you're writing generators, you don't keep everything in memory at the same time. You kind of lazily just ask for each of the names here, then you capitalize one by one and just forget what you've done. When you have a list of this size, it hardly matters at all which one you're doing. But when you have entries that are quite big, then it starts to matter quite a lot if you're keeping everything in memory or not. So before we look at a kind of real-life example, or at least a simplified real-life example of how I would use this, let's just also look at what's called generator expressions. So if you look up here again with kind of the capitalized usual, then I use this syntax here. And this is a list comprehension. I'll talk more about comprehensions in a different video, but you can see that you're creating a list rather smoothly here by just this one-line syntax. And you're indicating that you're creating a list because you have these square brackets here and here. That looks nice, right? But what you can do is to make generators this way as well. Let's just have version 2 to be able to separate them. Then I can do exactly what I did here, but I take parentheses around them. This indicates that I just want the generator. So now again, if I print this, you'll see, yeah, this is a generator. And again, I can print things by using usual for loops. In fact, I mentioned that really generators are just special iterators. And for iterators, a for loop is essentially just calling this next function all the way until it gets this stop iteration thing. So that means that I can also just manually, if I want to, call next here. Then I get IREC, then I get John, then I get Stina, then I get Alex, and then I get the stop iteration. So I really want to emphasize with these two things. One, you can often use generator comprehensions to get super smooth and clean syntax. This is amazing, I think. Secondly, generators are just iterators, so everything you learned about iterators with next and iter and this kind of stuff also works here. So generators are iterators, but not necessarily the other way around. Iterators don't need to be generators, because with iterators you can implement this dunder iter and dunder next method, but you can also have a lot of other functionality inside a class. Think of helper methods or things that alter the state of things and so on. But with generators, they're kind of straightforward in the way that they can just be written as a function here. So I try to think of generators as simple iterators that can be just initialized either with this nice function syntax or with this generator syntax. And the final thing before we go to the real-life example is that Python actually have some of these generators as usual built-in functions. For instance, the range thing here, so let's do range from 1 to 10. And now if I try to print this, here the printing is slightly nicer than just saying generator object and so on, probably not to scare away beginners, but it will still just say, yeah, this is range from 1 to 10. It doesn't specify the numbers. So if you pass it into a list constructor, like you could do like this, then it gives you the numbers because it essentially generates all of them. But range is just a generator, so it doesn't generate anything. It simply says, okay, when someone asks me to, I need to start generating 1, then 2, then 3, and I'll keep track of where I am, but I won't generate anything as of now. And the reason you can really see that this is a generator, one of the kind of funnest way, is just to do, okay, what if I do this? So here when I run it, you can see, yeah, this is range from 1 to whatever this number is, so it doesn't compute anything. You'll not run out of memory, so it's not computing anything. So some of the basic functions that you have in Python are actually generators. So some of the basic functions you're used to in Python are generators, so they're not really that foreign of a concept. Finally, I just wanted to give you some kind of real-life example of a generator. So the thing is, when you're reading in CSV files, and maybe here checking that the CSV file contain maybe some hashtag, this is a bit contrived, but say that you're looking for a specific name or a specific entry, then you can load in the whole CSV file into your program and into your memory. That's possible, but not really when the CSV files grow too big. So if you get CSV files from, for example, the export of a database, then they can be super large, and you really don't want to import 50 gigabytes into your working memory. With file sizes rather big, you'll either completely run out of memory and it will crash, or you'll simply consume a lot of your memory, and that's not good for systems either. So what you can do is to use generators. So I've already pre-written this code, but I'm using the CSV library. Here I have a function that reads in one line of a CSV file at a time. So it opens the path that is specified. It uses the CSV.reader to turn it into a CSV object here. And then for each row, it yields a row. This is the important, it yields it. So this here is a generating function, meaning a function that gives you a generator. And now we have another function called check for a hashtag. Again, takes a path and simply applies the first function here and loops over it. So it takes for each row that this gives me. So this thing here gives me the yielding here of each row, and for each of these rows, then I look at each entry in the row. So this is a CSV file. We'll look at a concrete example when I use it, but the rows have entries, and for each entry, I simply ask if the hashtag is in the entry, then I print I found it at row, and the row and entry, right? Typically in practice here, instead of just printing it out, I would maybe save this to some file or do something with it, maybe alter them in some way, but not in this video. In this video, I just print it out for simplicity. Then I run this check for hashtag at the test file. And here is the test file, name, age, and gender, in IREC12M, Stina with the hashtag 45S. So it has a hashtag here, so we wanted to find this. So let's go back to the program. And now I run this and it works. So it found it in row, this at entry Stina. So this works as intended, but the important thing is that this CSV file didn't need to be 3 lines long. It could have been 10 million or 100 million, as long as I have the power to actually compute this. Because what it's doing, if you look carefully here, this is the generator thing that's going on here. It's giving me each row, and once I'm finished checking the row, it simply puts it away, leaves it from memory, and then I put it in a new row and so on. So it doesn't get to the point where my memory is completely stuffed with rows because I'm reading in the whole thing first. Personally, generators are super useful when you're reading in a lot of data and searching for things. It doesn't need to be CSV files, it can be whatever, as long as you're reading in a lot of data, so having a lot of things in memory, it's always a good idea to think about, hey, do I really need to keep all of it in memory at once? Here in the CSV example, I don't need to understand the interrelation between row 45 and row 75. I simply need to check each one separately. Once I'm finished checking it, I don't need it anymore, so I can let Python delegate it away from memory because I don't need it anymore. So that's what I wanted to say about generators. To get started with generators, I simply suggest that you write some generator functions and try it out. It's really not that hard, and it's a super useful trick for being able to have more performance in your programs. So if you like the content we're providing here, then like and subscribe, and I'll of course see you again in the next video in this series. Thanks, and have a nice day.